The next applications for trig functions is the area of a sector. A sector of a circle is a portion of the interior of the circle intercepted by the central angle as displayed here in the diagram. In other words, this is like a piece of pizza or a piece of pie. And what we want to do is to determine the area of this sector. And the way we do this is by the given formula. Area of a sector is equal to 1/2 the radius squared times theta, or the degree of the central angle, and that central angle has to be in terms of radians. Our first example asks us to find the area of a sector with a radius of 12.7 centimeters and an angle theta equaling 74 degrees. Recall that our formula is area of a sector is equal to 1/2 r squared theta. Now, all we need to do is substitute our known values into our formula and then calculate for the area. But the first thing we need to do is convert my theta, which is in degrees, into radians. Let's recall the procedure to convert degrees into radians is to multiply my degree times pi over 180. And then what we do is simplify. When I simplify, I'm going to get my radian measure for theta to equal 37 over 90 pi. In other words, I just divided each of these two values by 2. Let's substitute our values into our formula. 1/2 r squared, r is 12.7, and our theta is 37 pi over 90. Now, I'm just going to substitute this value into a calculator and determine the area of our sector. From the display in the calculator, the area of my sector is going to be 104.2 centimeters squared. The next example wants us to find theta in degrees when the area of the sector is 25 centimeters squared and the radius is 4 centimeters. Let's first recall that our formula for area of a sector is A equals 1/2 r squared theta. And theta is in terms of radians, and our final answer needs to be in terms of degrees. But we can substitute our known values into our function and then solve for our theta and then determine what we need to do for it after that. So here we're given that our area of the sector is 25 centimeters squared equals 1/2, and our radius is 4. And what we need to find is theta. Let's simplify our function and solve for theta. 25 equals 1/2. 4 squared is 16 times theta. Then we simplify again. 25 equals 16 divided by 4 is going to give us 8 theta. And then when we divide, theta is going to equal 25 over 8. Now we're going to substitute that value in the calculator and get our solution for theta in radians. Here, we're going to get theta to equal 3.125 radians. Recall, to convert this to degrees, we're going to take 3.125 and multiply by 180 over pi. Then our solution will be, when we plug this into a calculator, approximately 179 degrees.